the last talk of the day. I'm sure you guys are all super excited. It's a long day. It's a long day and a lot of good talks. And you saw the 3 framework talks from TensorFlow, and Yangqing gave a generic talk, and then Alex gave a talk on MXNet. All right, I'm here to talk about Torch. Wait, there should be a slide. All right. So, not only will I talk about Torch. Wait, I need to figure out how to go to the next slide. All right. Not only will I talk a little bit about Torch, I will also talk about what today's AI is like and how the tools we are using today are suitable for today's AI. And then I'll talk a little bit about what the next generation AI is starting to become and how we have to change our tools to adapt to the situation. So, and that would sort of set the tone for the talk. So, to give a very brief and quick overview of Torch, Torch is a scientific computing framework, just like MATLAB or, say, Python with NumPy and SciPy. It's an interactive framework with REPL, a console. You can type commands and they will be executed. And Torch has a strong tensor library. Tensors are just like n-dimensional arrays, and you can do a lot of different math on them, and a lot of deep learning is done with tensors as their fundamental building block. TensorFlow is named after. So we have everything you expect from a scientific computing framework. We have plotting and everything else. We have IDEs and so on. And we have a very easy and seamless integration into calling C functions. So you can write your Lua code and then you can simply call arbitrary C functions from your Lua code and back and forth. So it basically Torch serves as like a Lua layer on top of low-level C libraries. And the biggest and most important thing we have is strong GPU support. We have a very fast tensor library that we built from scratch over several years, and that we continue to develop, that a lot of our users love. All right, and we have packages in Torch for building neural networks, building standard convolutional networks, LSTMs, everything under the sun, and we have Torch has a view of neural networks as blocks, so you can have a convolutional block and a pooling block and so on, and you can stack these blocks up in various ways, and that's how you build neural networks in Torch. And apart from just having a block view of the world, you can think of writing arbitrary computations and you want to differentiate with respect to them. And Torch is a framework written by several users and communities and companies. And so it's not unusual for, say, a big company to contribute a package that's based on Torch. So Twitter had written this package called Autograd, where it gives even more flexibility to do neural network research, especially like the new type of dynamic neural network research, where you just write your function as like a standard Lua function that does arbitrary things, and then your backward pass is written for you. And you can use any construct in the language itself to be differentiated. And for distributed learning, we have an inbuilt multi-GPU support in Torch in the core itself, but we also support training neural network models on several machines using the discipline package, also written by folks from Twitter. So we have all the basic capabilities that everyone talks about when they talk about deep learning frameworks. But not only all of these, we have a very large community of people. Torch is not backed by a single central company, but it has a very rich ecosystem of a lot of users who contribute back in various ways, and it just makes our development a lot richer and diverse. So we have a core philosophy in Torch. We have like 4 things we try to keep around, which is the first one is interactive computing. When you're doing research, you don't know what you want to do next. So you keep a terminal around and you try different things, and then you want to change what you want to do. So like, we think the interactive computing aspect is pretty important. And the second thing is imperative programming, which is, as Alex pointed out a little bit about imperative programming, but basically, as soon as you type a command, it gets executed, and there's no magic around that. That's imperative programming, and that helps you think and debug things very easily, and we think it's pretty important in like a scientific computing perspective. Minimal abstractions. We try to minimize the number of libraries or abstractions we have between the code you execute and the actual code, optimized code that gets run. So that way, if our researchers ever want to just write some routines in C or C++ quickly and interface them into Torch, they can do this with almost no pain. And we want maximal flexibility. By that, we don't want to have like a constrained view of the world by only building a particular type of neural network and running that again and again without changing things in between or ahead or after and so on. So we want to minimize the constraints we put on our researchers so that they can explore all the ideas they have. And the community itself is very rich. There are several companies that work on Torch and support Torch, and there are several universities as well. In the Bay Area, I think there's like a slight lack of companies there, probably dominated by other frameworks. But in general, we have a very healthy community all over the world. So some projects from the community, we have like converters from like to load models from Caffe or vice versa, and then we implement state-of-the-art image classification and detection models, and we have popular projects that take an image and spit out a description of what's in the image. And one of the most popular projects we have is the Neural Style project. It's been a big rage to take a photograph and modify it in the style of some painting. And so one of the earliest implementations of Neural Style ended up being really popular, and you can actually find several commercial products that implement Neural Style that simply have the Torch code in them. And we have a new project from Harvard and Systran, which is a big machine translation company. They started a project called OpenNMT, where you have state-of-the-art machine translation available to you, fully open source, free, and ready to use with like a C++ deployment script as well. And you have fun projects where you can draw some doodles of a rough sketch of what you want, and then an image will be generated. And we have integrations into various gaming engines to do like new age AI research. And generative image models, that was an example I wanted to show. Alright, so that basically ends my sell on Torch. It's like, oh, why should you use Torch? Like, okay, let's use Torch for these reasons. Like, now I want to talk about what else do we want to do with Torch? What's the future? Torch has been the same design for about 5 or 6 years now, and it's served all of our purposes so far without problem. But the world is changing and the AI research community is changing. So today's AI, what by today's AI, I mean like the stuff that we use today that's reasonably solved to be used in production in various ways. Stuff like image classification and image detection, or video classification detection, etc. Or you can take of, say, segmentation in images and, say, medical data and so on. Or you can think of various text problems, like text classification, embeddings, or like ads ranking, machine translation, and so on. This is what I call today's AI. We know how to solve it to a reasonable state that we are deploying these things in production. So what is next? What's happening? Today's AI is all about static data sets and static model structure. Model does not change over training time, and everything is basically offline learning. That is, you take a big data set, you take a big model, you train them up, you get the model, and then you deploy it into production. So this is the current state, but when you go to a cutting-edge conference like NIPS or ICML, what's the new age research that you're seeing? Where is the field progressing? You see a lot of new research where there's agents training in different and new environments. For example, OpenAI released a new project called Universe, where you can train in thousands of environments in an interactive and online way using, say, reinforcement learning. And you have online learning happening all over the place. Self-driving cars are starting to be almost ready for general consumption. And they, like some of the self-driving cars, have online learning where they adapt to the situation, they learn from the situation. And you have a lot of research where you have dynamic neural networks. The neural network, while it's training itself over time, it will try to change its structure, add some memory, and it changes the way it behaves based on the environment, and so on. It's a very dynamic world. So, and lastly, one of the trends we've seen is like you have a lot of what we call structured prediction, which is that you have like a large neural network, and then you have a tree search kind of algorithm at the end that will try to predict ahead of time and pick the best path. So, keeping all this in mind, this is what I think, this is the direction we are going towards with the Torch framework. And in the next coming months, we will share our new versions of Torch. Making your framework interoperate with a variety of environments, whether it be static data sets or dynamic data sets, or environments themselves, including the real world. And then having a rich scientific ecosystem. Neural networks are not the only thing on the planet. I mean, right now they're the most popular thing, but future research also entails that we explore every different idea possible, and limiting ourselves to have the framework only operate with, say, its own libraries or packages will limit the ability to innovate. So interoperating with rich scientific ecosystems like SciPy will really help. Then dynamic neural networks, where you simply define a neural network in an arbitrary way and differentiate it backwards. That's, I think, one of the things we think are pretty important. Minimal abstractions. If you want to implement a new operator in C or some low-level language, you shouldn't have to have like 6 different steps to follow before you actually call that thing in your code that you're using in a high-level language. So minimal abstractions. That also helps with ease of debugging. And lastly, as both Rajat and Alex pointed out, we need graph compilers where they can take in a computation that needs to be done and compile it on the fly, maybe fuse some of the tensor operations or like more efficiently parallelize and so on. And graph compilers are not necessarily incompatible with dynamic graphs. You can have a system where you just in time compile the computation you're trying to do. So that's a preview of our thinking and what we plan to work on and release in the next few weeks to months. And the last slide, I want to say, I share the view of Yanqing and Tianqi, who works on MXNet, is that let's share the low-level libraries, and we can build different high-level frontends for different purposes. We can share not only the compilers, the graph compilers, or like the general-purpose compilers, the tensor libraries, the specialized neural network libraries like cuDNN or MKLDNN, the distributed computing part like Nickel or MPI, and let's embrace a Unix philosophy, because in the end, like a bigger community that shares everything will just probably win over someone trying to reinvent everything by themselves. Thank you.
Closer to an answer. So let's start very end. You said 1500. 1501. That's there. $999. You guys need to go up. Where do you go? Where? Look at the chat. Sue. Yep. Yep. 750. Yeah. 1400. Okay. So I think you guys need to go above 1500. There. 2000. Okay. I think one last. 1700. Okay. So who was closest to 1600? So we have 1599 registered attendees. 1501, I think, is the one. So you get the price. And the price here is Google Home. And to conclude the conference, I will invite Julie, please.
We are going to end today's session. If you are coming tomorrow we have two parallel sessions. One is training, both will not in this room. Training will be all the way in Great American Ballroom. The startup presentation will be in upstairs, Great American meeting room. And if you are not coming tomorrow, next year we will continue to have this conference. We already set the date, so mark your calendar, January 13th and January 14th. All right. Thank you. Good night.
What?